In this video, we will cover leave one out cross-validation. Now, cross-validation is a technique that we can use in machine learning in order to evaluate the performance of a predictive machine learning model. Now, the structure of this video will be as follows. First, I'm going to outline what leave one out cross-validation is, and I'm going to use a very simple visual example in order to convey this idea to you. And afterwards, we're going to jump into a Jupyter notebook where I will show you how to implement this type of cross-validation using scikit-learn. So without any further delay, let's jump into the video. Now, leave one out cross-validation is an exhaustive method of cross-validation, meaning that we are going to try to make use of every possible combination of split in our data as part of this technique. Now, normally this results in a very large amount of splits that we need to run through. If you recall from my previous video on leave P-out cross-validation, we actually ran into this with a very small data set. Now, leave one out cross-validation is a simplification of that leave P-out algorithm. More specifically, what we do with leave one out cross-validation is we fix the size of the subset to be used for testing, which is P. We fix that to be 1. And this will result in the smallest number of possible splits that we will need to do in order to evaluate our model. Now, to convey this idea, let me show you just a very simple visual of how this actually works. So here we see a very simple data set consisting of 4 samples. Each one is color-coded. Now, if we want to do leave one out cross-validation, we select out one of the samples for testing and use the remainder for training. Here you can see how this is being arranged. Now, this results in 4 possible splits that are illustrated here. For each split, we have the unique sample that's being used as our test set, and then the remaining 3 samples are being used to train the model. And this is basically it. This is exactly how we're going to run through our cross-validation technique. Mathematically, we can say that what is going on here is that we have n choose 1 splits. Now, n choose 1 is just going to be equal to n. So n being the number of samples that we have in our data set. So this is always going to be the number of splits we are going to have as part of our cross-validation. So I hope this illustrates the concept that we are doing here. Now let's jump into a Jupyter notebook where I can show you how to implement this in Python. So here we are in a Jupyter notebook, and note that this is actually the same notebook that I used in my previous video for leave P-out cross-validation. I've just updated it and added a few more cells for us to do our experiment with leave one out cross-validation. So we're going to start by running the first cell here, and this is going to import all the packages that we will need for our experiment. Okay, and now we are going to create a simple toy dataset. This dataset is the same as what we used previously. Namely, it is going to consist of 50 samples with 10 features, 5 of which are going to be informative, 2 of which are going to be redundant. Now, we're going to keep things simple by using a binary classification dataset. So I'm setting the number of classes here to be equal to 2. These 2 classes will have a very simple imbalance with them of 0.4 to 0.6 for each class respectively. I'm also setting the random state to be equal to 42 so we get reproducible results. So let's run this to make our data, and also we will be making use of a simple decision tree classifier here as the model we're going to use for our experiment. This classifier is going to have a maximum depth of 10. So we can just run this. And now I'm going to scroll down to the section now for the leave one out cross-validation. So the first cell that we have here is just declaring an instance of our leave one out class. So we can see that here. We imported leave one out. If we scroll back up, we can see that we brought that in from scikit-learn model selection. You can see that here it's the same place where we imported the leave pout cross-validation from the previous video. So all we're going to do is declare an instance and then get the number of splits that we're going to make for our test set. So you can see here we're just calling this method called getNSplits, and we feed it the input training data that we're going to make use of. So let's run this cell, and should be no surprise to anybody now that the number of splits we are going to have is 50. And this is just simply because the number of samples we have in this data set is also equal to 50. So if you remember, leave one out cross-validation is just n choose 1, which is just going to be equal to n being the number of samples we have in our data. Okay, and the interesting thing here too, if I can compare this also with what we saw previously with leave pout cross-validation, is that if you remember in that previous test, we set p to be equal to 4 on the same data set, and we had about 200,000 splits for that experiment. So you can see here there's a dramatic reduction in the number of splits that we are going to need to do in order to conduct this evaluation. So that's already a big, big difference. Now we're going to run this next cell. You can see here that I'm going to time the computation. And what we're doing here is we're just going to iterate through all the possible splits. So from our object, our leave one out object that we just initialized, we are going to extract out the indices for the different samples, how they're going to be allocated to either training or test on each iteration, so on each split. So we extract out these indices, and then we use those to split our data into training and test sets. We can fit our model, and then we can store the results. So we're going to store the true labels first, and then also the model predictions. Then we can use those to compare the two at the end. So let's run this cell. And we can see that ran pretty quick. It was just under 40 milliseconds. So that's really fast. If you remember, for the leave pout cross-validation, it took about 1 minute to run. So this is a huge difference. This is quite a bit faster. Now let's measure the performance. So we're going to compute the accuracy, precision, recall, and F1 scores. And here we can see that these results are somewhat similar to what we got previously. In some respects, some of these values are actually just a little bit better than what we saw, but in general, this is pretty similar to what we saw with leave pout cross-validation. But the big difference is the computation time here. Just because the sheer number of splits is so much smaller, we're able to get these results in just a fraction of what we saw previously with leave pout cross-validation. So this concludes the video. If you're interested to take a closer look at the code that I shared here, this notebook is available on my GitHub. You can find a link to this notebook in the description below. Now, if you learned something from this video and you enjoy this content, please like, share, and consider subscribing to the channel. Your support is greatly appreciated. Have a great day, and I'll see you in the next video.